Welcome students in physics class 12, Coulomb's law and electric field, video number 3. In this video we read about the concept of electric dipole. The concept of the electric dipole is when two equal magnitude and opposite charge are placed very small distance to each other. When two equal magnitude and opposite sign charge are placed very small distance to each other, then they form electric dipole. Then they form electric dipole. The example of electric dipole is HCl, H2O, etc. HF. These are the example of electric dipole. It is seen that when two different elements having different electronegativity, they form electric dipole. Because you know that in HCl, the electronegativity of Cl is high, the electronegativity H is low. That is why when they share electron, the share electron are Cl attracting more than H, these share electrons. So it is having a small negative charge and it is having a small positive charge. They form electric dipole. This is the example of electric dipole. And from electric dipole, the electric dipole moment is when two equal magnitude and opposite sign charge are placed very small distance each other, then the product of the single charge and the distance between them is called electric dipole moment. It is denoted by P. P is equal to Q into 2L. Without sign we take any charge and the distance between them is 2L. That is electric dipole moment. Electric dipole moment is a vector quantity. The direction is from negative to positive. And its unit is Coulomb meter. Coulomb meter. And dimension is ATL. That is the dimension. This is electric dipole moment. And very important formula, derivation of electric dipole moment. It is seen that when any electric dipole is placed in external uniform electric field, it experiences a torque. What is the formula of the torque we read about? Suppose this is uniform electric field. Formula of torque acting on electric dipole in a uniform electric field. Suppose this is uniform electric field in which any electric dipole which is made of minus q and plus q charge and distance between them is 2L. When it is placed in external electric field, making a theta with the direction of the electric field, as well as it is placed in the electric field plus q charge experience of force F is equal to QE in the direction of the electric field, and minus q charge experience of force F is equal to QE in the opposite direction of electric field. These two equal force and opposite, so these two forces are equal and opposite, they form dipole. And the value of the dipole, electric dipole, they form dipole, and the value of the dipole, it is denoted by tau. Tau is equal to force into perpendicular distance. Perpendicular distance. Force is F and perpendicular distance is we draw perpendicular line, that is perpendicular distance, and this value is obtained by sine theta is equal to perpendicular upon 2L. This is perpendicular distance P upon 2L. So P की value, the value of perpendicular distance is 2L sine theta. So when we put in place of 2L sine theta, and the value of F is QE into 2L sine theta, and Q into 2L is electric dipole moment. If the electric dipole moment of electric dipole is P is equal to Q into 2L. So tau is equal to PE sine theta. This is the formula of the torque acting on electric dipole when it is placed in uniform electric field. When theta is 0, it means when electric dipole is placed parallel to the electric field, the torque is 0. Theta sine 0, torque minimum, that is the minimum torque is 0. Because when the electric dipole is parallel, these two forces are equal and opposite and their line of action is same. they cancel to each other and the resultant force is zero. So torque is zero. And when theta is 90, torque is maximum, because the value of 90 sine maximum, sine 90 is 1, that is maximum, is P. Maximum torque is P when the electric dipole is placed perpendicular to the magnetic electric field, uniform electric field, it experiences maximum torque. But this formula is applied when the electric dipole is placed uniform electric field. When this electric dipole is placed in non-uniform electric field, there is no torque act, because some at that place force is high or low, at that place force is different. When these forces are different, they don't form torque. So when the electric dipole is placed ununiform electric field, there is a resultant force act on the electric dipole and no torque. And when it is placed uniform electric field, there is a torque act on it and the resultant force is zero. These two forces are equal and opposite. That is why they cancel to each other. Resultant force is zero but torque active. That is.